This goes in your Unit 5 notes. I'm going to pass out a paper here real quick. You do not need to copy these down if you don't want to. But I want you to take a look at these 4 graphs I have drawn, and I want you to think which one of these is a function. Now, you probably don't know what a function is yet, right? If you do, wonderful. Don't ruin it for everybody, Naya. All right? Which one of these is a function is the question. Now, one way you can determine it's a function is to think, can I graph that on my calculator? I said graph, not draw. Okay? There's a draw function on your calculator. Okay, that's not what I'm asking. I'm asking, can you put an equation into your calculator that'll graph that line? That's one way to think about if it's a function or not. All right? And then I'll give you some other ideas about how we know it's a function or not. So, while I'm passing these out, while I erase the board, I want you to try to figure out which one of those are a function. If that means you're trying to put it in your calculator to figure it out that way, that's fine too. Extras. A math teacher can't count, huh? Man. It's like an elf who wants to be a dentist. I didn't give you one of those, I'm sorry.
Did you just say an elephant?
An elf who wants to be a dentist.
How do you say elephant?
You never saw the Rudolph the Red-Nosed Reindeer story? The little claymation one?
Yeah, I have.
There's an elf who wants to be a dentist. Alright, never mind. Alright.
Don't use that word.
Which one's a function? 1, 2, 3, or 4? Who thinks 1 is a function?
Me.
Raise your hand if you think so. 3 people. Nice job. Okay, who thinks 2 is a function? You can make 2 on your calculator, Luis? No. You can't? Okay, we still think it's a function? Alright, that's alright. Alright, who thinks 3 is a function? Tony? No? I called you. No, hands down. Stand up. Justin, you think it's a function? No? 4?
The guy outside of me.
The guy outside, you said yeah. Okay, is 4 a function? What do you guys think? So the only one where we had more than 1 vote, or we actually had confident voters, was number 1. Okay. Why is that? Have you all made a problem on your calculator before?
Yeah.
Okay. You've all probably made something like this before on your calculator, right? None of you probably ever made this, or that on your calculator, which is good. You have made before? Wonderful. Okay. Maybe we'll learn how today too. Okay. So, which one's a function? You guys all said 1, so I'll put a little star by 1. Okay. Put a little star by 1. So that was one we voted for. All right. Are there any questions before I move on? Does everybody have a copy of the note page? Yeah. Okay. The first thing on your note page is, what is a function? Okay. It's like conjunction, junction. What's your function, right? You're just thinking. I think it every time too. Anytime someone says function, I think of that song which has nothing to do with functions. Okay? Because that's about commas and stuff. Right? So, this is still Unit 5, and this is Lesson 1, Investigation 1. Okay? And it's what is a function? A function is a rule that assigns only one output to every input. A rule that assigns only one output to every input. I'm going to underline only. What does only mean? 1. Right? Right? Only means just 1. That's it. No more. Right? The parent says you can only have 1 cookie. How many cookies do you have?
5.
5, okay. We listened to our parents. All right, so only means you're just supposed to have 1, right?
No.
No? Okay, it does. All right. If you need to look it up in the dictionary, only means that we just get one. All you get is one. So what it's saying is a function is a rule where every input has just one output. Okay, does that make sense? Every input has just one, only one output. But to tell my 2-year-old, if I say only one, I just say just one, and she looks at me and goes, just one. Pretty funny. All right, but she does that. It's cute. So only one means only one. It's not like only one, like when Grandma says only one cookie, and she's okay if you have 10. All right. She didn't mean one package, right? All right. So does this make sense? This makes sense, guys? Okay. All right. So next question is, what's an input? What's an output? Which one comes first?
Input.
Input, right? You put something in, get something out, right? That's how it works. So let's think about a rule. What's a rule we looked at before? Rules are like y equals equations. Someone give me a y equals equation.
2x.
2x
Plus 4.
plus 10. Okay. Could have used plus 4. Someone said plus 10 first. All right. So y equals 2x plus 10. If I want to graph this rule, this equation, what do? Draw a line. That's good enough, right, Long? No, it's not good enough. Because you didn't go through the right points, did you? If you just draw a random line, it's not. It might be right.
Yeah.
I got a higher probability that's not correct. Okay? But it might be right if you just draw a line. It's possible. Not likely. How do I make that line? If I want to graph that line on an axis, how do I make that line? You guys have a question? No? Cold?
No, it's because I eat a chocolate that has peanut butter inside, and I'm allergic to peanut butter.
You're allergic to peanut butter. You want to go to the office?
Huh?
You want to go to the office?
Sure.
Yeah, it's probably a good idea. All right, tell them what happened, okay? All right. All right, so y equals 2x plus 10. That is a rule, right?
Yeah.
I want to graph that correctly. What do I have to do? Put what in the calculator? So go to my y equals and put that in there?
Yeah.
Okay, that's one way, but then my calculator is going to do the same thing I'm trying to get you guys to say. If I want to make that by hand without a calculator, what do I have to do?
Find the X and
I need a ruler. You're going to find what, Whitney?
the X and Y.
The x and y intercepts. That's one way, right? Is that the easiest way?
No. Gotta get a
Probably not.
Okay, plug what in, China? You put it on 10. Okay, so we know 10 is 1 point. How do you find the other point then? So you're going to do it that way? Of course you would.
That's what
All
I
right. You were thinking that too? That is a good way to plot the line. Man, you guys are catching me by surprise. See, I was going to think that you would say we'd plug a number in. Where would we plug a number in? X, right? And when we plug a number in for x, we get a y. And then that x comma y would be a point, wouldn't it? So which value is our input? The x. We plug into x. We put numbers in for x. It's the input. Okay? We get out the y. Okay? So inputs these are all the x values. Okay? It's what we put into the function. Now there will be functions where they're not going to be they won't be functions of x and y. They might be of like h and t, height and time. Okay? They might be of I don't know, we've done plenty of functions where it was like I can't think of it right now. Cost and number of students, right? C and n, right? We've done different functions like that. So, but the x values, what variable is the x value? Independent or dependent? It's the independent, right? So whatever value you can choose, that's your inputs. Okay? All right, and the output then is what function? Is what value? What do you guys think? It's the dependent variable, which is usually the y values. Now, all the x values make what's called the domain. Okay? The domain is all the x values. Okay? Domain equals all the x values. So not just the ones you have in your table, but all the x values that will be on this line, right? Because if I asked you guys to graph this line, you'd probably give me whole number values. You'd probably put in 1 for x, and you get 12 for y. You might put in 2 for x, and you get 14 for y. Those are whole numbers, right? Right? If I graph this line, would it go through decimal points?
No.
It wouldn't?
Yes.
It'd be a straight line, never ending, right? It wouldn't just be a bunch of dots. If it only went through whole numbers, it'd just be a bunch of dots. Okay? But this line right here, if I were to graph it, it wouldn't look like this. Right? That would just be the whole numbers. Okay? It would look like this. Oh, I missed my point. Nice job. Okay? Showing that it goes through not just the whole numbered points, but it goes through all of the decimals. Right? If I plug in 2.3 here, it's going to give me an answer, right? Yeah, it's going to be 12.3. Or no, sorry. 14.6. Okay? Alright, so if I plug in decimals, I can get decimals out. So the domain of this function would actually be all numbers. You can plug any number in, and I'll get an answer out. Okay. Alright, the y values. Yeah, it's the range. Okay. The range is all the y values. And we'll explore this more later. Right now, we're just focused on what a function is. Okay. What? Oh, we'll get to that more later. And we also said the inputs are which ones? Independent or dependent? Independent. And then outputs are the dependent. All right, any question about what a function is and what the input and output are? Any questions? All right, now, I believe it shows a good understanding of a concept if you can rewrite the definition. Okay? So what I would like you to do, function has a definition there, right? That is the definition of a function. I would like you guys to rewrite the definition of a function using x and y instead. Okay? So I would like you guys to rewrite the definition of a function using x and y. Alright? So take a moment here and rewrite the definition of a function. Everything okay, Joanna? Okay. Long, what are we doing right now? Nothing. Rewrite the definition of a function, please. I should send my YouTube videos to you guys as parents. Wow, why is the teacher always calling on you? Yes, Bruno. No, you don't. It's not that exciting. It's just a paper that I made. Yes, sir. All right, and we got a definition, a rewritten definition. You want to share? Naya, what'd you write? So it's a. I missed that first word. Someone look at the screen.
So the function is when there is only one x value for every y value.
Okay, so a function is when there is only one x value for every y value. Is this right? The way this is written, a function is when there's only one x value for every y value. Could two y values have the same x then?
No, because if they repeat, then it's not a function.
So a function is when there's only one x value for every y value.
Then it should be for every one for every x value.
Okay. I think you have your x's and y's. Yeah. Long, you were right. I know. I was going to give you the credit, Long. Okay? So it should be written this way. A function is when there's only one y value for every x value. Okay? Every x only gets one y. There's no stipulation on the y's. one y can have multiple x's. But every x only has one y. Any other way to write this? Yep. Any other ways? No other ways? So a function is when there's only one y value for every x. That's the only way we can write it? About this. Each x has just one y. Is that another way? Each x has just one y. Each input has just one output. Yes, Tony? Can y be the same as x? Can the numbers be the same? Yes, they can both be 1. All right? Okay, any questions? Okay, so that's what a function is. All right, so let's use this idea of a function. Let's apply it to our 4 graphs over here. Okay. Let's apply it to our 4 graphs. So here's our 4 graphs. Sorry I didn't include these in your notes. That was just I thought about this morning when I was thinking about it. So that's where this whole graph came in. Oh, darker so you can see better. So, are there any new ideas about which one of these is a function? Okay. Are there any new ideas about which ones of these are functions? All right. Which line on the graph has all the same x values? If I want to draw a line on one of these graphs that has all the same x values, how would I draw that line? Straight line, which way? Straight up? Okay, there's opposing opinions, right? So let's say I have this axis right here. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay. So, Long, your first inclination was to draw a line that goes straight up, right? There's my line that's going straight up. Right? Then Tony distracted you and said, no, it should go which way? Sideways. So the question is, which line has all the same x values? The black line or the blue line? Let's plot some points. What's this point right here? 0, 2, right? What's this point right here? 1, 2. What's this point right here? 2, 2. I don't have one, but on the way, right? All right. So are those all the same x values? 0, 1, 2. Are those all the same x values? No. This is a horizontal line, so all the y's are the same. Right? Now if I look at the black line, this point right here is what? 2, 0. This point right here is what? 2, 1. This point we already said was 2, 2, right? What's this point right here? 2, 3. What's this point right here? 2, -1, right? And we can keep going. We could include. Oh, this isn't a function yet. We're just asking which line is which. Okay. We could even include the decimals, right? The one right here between the 0 and the 1 would be 2, 0.5, right? But every dot on this line, doesn't matter where I put it, if it's on this line, we know the x value would be 2. So what type of line is that? Vertical. That is a vertical line. Right? So, using a vertical line, can you figure out which one of these is a function or not? So, how could I use a vertical line to see which one's a function? Does anybody know? You already know the vertical line test, or are you just reading off the paper? It doesn't say it on there, so how do I do it, China? If it repeats. A little louder now. Okay, so if I have a vertical line and the graph hits it more than once, then it's not a function, right? Because isn't this vertical line isn't this my x's, right?
Yeah.
The function rule says each x has how many y's?
One.
1. So if I draw a vertical line on this graph anywhere, and that graph hits that line more than once, that means this graph has how many y's for that x? 2. Okay, is that allowed? No, so that wouldn't be a function, right? So, Long, you're going to say something? Nothing? Okay, so here I have a nice vertical line. Okay, anything that's straight, like a pencil or a ruler, or even the edge of another piece of paper, can be used for this. Some cell phones, yes. Other cell phones, no. Some cell phones with rounded edges doesn't work. All right. So, I know you guys always hate your cell phones. So here's my vertical line, right? I'm going to pass it across graph 1. Tell me, say something, maybe make a buzzer noise, right? If my vertical line ever hits this graph more than once, for graph number 1, okay? Hey, let's try the buzzer out real quick. 1, 2, 3, buzzer. Ready? 1, 2, 3. There we go. Okay. Thanks, Whitney. Okay. Tony, yours wasn't as loud. It can be a beat. That's fine. All right. So, do I ever cross this? Okay, I didn't hear any buzzers. Right? No, it's good. There wasn't supposed to be a buzzer because this graph only hits my vertical line once everywhere, right? That means that every x value has only one y value. Okay? You can think about it this way. If I draw a line, if I draw a vertical line on my graph, right? I'm going to draw this line right here. We'll draw a vertical line right there. It hits right there, right? What's the x value? -2, right? What's my y value? 1. Okay, it looks like it might be 1, right? Okay. Has an x and a y, an input and an output. Does that make sense? Okay, so is this one a function?
Yeah.
Yeah, because each x had only one y. Okay, good. Let's try graph 2. You guys ready? A little late. Our vertical line buzzer was a little late there, but this vertical line. Right, you're waiting for. You don't want to be the only one.
No.
Okay. This vertical line, once it hits this blue line right here, how many times does the blue line intersect my ruler? Twice. Okay. So if I draw my vertical line like this, that x was supposed to be -2. Okay, it's supposed to be a -2 right there. Right? How many times does the graph hit it? Twice. So that means that there are how many y's for -2? That means there are 2 y's for -2. Is that allowed? No, we cannot have 2 y's for -2. That means this is not a function. Okay, does that make sense? Okay. Are all the vertical line buzzers in order? We all ready now? Okay. All right. Let's try number 3. Okay, so here I'm bringing my vertical line. You guys paying attention or what? Okay. Does this pass a vertical line test? Does my vertical line ever hit this graph more than once? No. So that means every x has how many y's? 1. More than 1 or just 1? Just 1. Every x has just 1 y. So that makes it a function, Justin. All right? All right. So 1 and 3 are functions. Let's try 4. You guys ready?
Yeah.
I'm in the way.
Go the other way.
Wish there's a horizontal line test. It'd be so much easier. It's not. It's a vertical line test. You ready? Good. So the vertical line is fine right here, right? It only hits once. But once I get to this spot right here, I hit twice, 3 times, 3 times, 3 times, 3 times, once. Right? So out here it looks like a function, but here in the middle, there's some x values. Okay, nice straight vertical line there, Mr. Branch. There's some x values that hit how many times? 3. That means an input has how many outputs? 3. Does that follow the rule for a function? No. So, what you guys are just using is something called the vertical line test. Okay? we kind of explained why the vertical line test works. But what the vertical line test is, and you have some examples here, right? Is this a function? No, because a vertical line hits it how many times? Twice. So, on your note page, you can write down vertical line test. If a graph intersects a vertical line more than once, then it is not a function. Okay? So if a graph intersects a vertical line more than once, it is not a function. Okay. And the reason being is then some x's will have more than one y. Does that make sense?